Simplify and express your answer using positive exponents. Generally, it's best to start inside the parentheses and do as much as we can on the inside before moving to anything outside the parentheses. So we're going to choose a law of exponents that will handle this situation of a product of two expressions with the same base. Looking at the available options, I would say the product rule is our closest match. This has a product of two expressions with the same base and tells us that we want to add the exponents in order to combine the two expressions. So here we're going to add the exponents to get x to the power 5 and then go on to the power 4 that is outside the parentheses. For this next step, we're going to want a property of exponents that handles this power to a power situation, and the closest match to that is this rule down here that's called the power rule, and this tells us that we would multiply the exponents in order to simplify this expression. And therefore this next step can be accomplished by multiplying 5 and 4 to end up with simply x to the power 20. It's fairly common for the product rule and the power rule to be confused. So what we want to remember is that if we have a power to a power, that's when we multiply. And in this other situation where we have two expressions, each having the same base that are being multiplied, that is the situation in which we add the exponents. Going on now to the next problem, we have an expression inside the parentheses, and it is taken to a power 2 outside the parentheses. Again, we're going to stay with this idea that it's best to simplify the expression inside parentheses first. And the first thing I notice is that I do have two powers of x here, one on top of the other, which most closely resembles what we see in the quotient rule. This tells me that what I want to do is subtract the exponents. When subtracting the exponents, the first thing I want to do is identify where the larger power is. In this case, the larger power is in the denominator, and that means that my power of x is going to end up also in the denominator. So as I rewrite this expression, I'm going to subtract the exponents. 8 minus 3 is 5. I'm going to rewrite this whole thing. And as I rewrite it, I will put this power of x in the denominator. And since I have nothing left in the numerator, I want to fill in a 1 to take the place there. Now I'm ready to deal with this power of 2, and I'm going to need another property to help me handle this situation here. Product to a power and quotient to a power combined are the rules that we're going to use in the next step. Product to a power, it resembles the distributive law, but it's not. It's its own law. It says that if we have a product in parentheses taken to a power, it's okay to bring that power in and apply it to both factors. Quotient to a power says that if we have a quotient or something that looks like a division or a fraction all taken to the same power, it's okay to bring that power in and apply it individually. If we put those two laws together, we can see that it's okay to bring this power of 2 in and apply it to every single factor of our expression. So what that means is I want to figure out 1 squared for the numerator, and since 1 squared is 1, it just stays 1. 4 squared goes into the denominator, which would be 16. And then for x to the 5th squared, we need to think about this as though it were written out. When we write it this way, we can see that this is the power rule again, the situation in which we would multiply the powers, and therefore we will multiply 5 by 2 to get the power of x that we end up with in the denominator. So x to the 10